All right, so 4B, we'll talk about compounding. It's going to involve a little bit of arithmetic, so I'm just going to review a couple things. I'm going to go through this part pretty fast because I'll assume that most of you know this stuff, but the way our power rules work. So this is called a product of powers. So if I'm multiplying two numbers that have exponents that have the same base, I can simplify by adding the powers, right? So if you had like 2 squared times 2 to the third, that's 2 to the fifth. And likewise, if I have a quotient of powers, I can simplify that by subtracting. Oh, good Lord. Sorry. All right, so likewise, if I had 2 to the third divided by 2 squared, that would be 2 to the 3 minus 2, 2 to the first. So you always subtract in the order top minus bottom. Okay. Another situation that could arise is power of a power, in which case you would multiply the exponents. So let's just use my same example. If I had 2 to the third squared, that's 2 to the sixth power. And then just the way that roots work, right? When we're trying to evaluate some sort of a root, this thing here is called the index. And it tells you you're looking for a number that multiplies by itself that many times and will give you back what's in the radicand. When there is no index, it's understood to be 2. That's called a square root, right? So you could technically write that, but nobody does. All right. The other thing is you can write any root as an exponent using this rule. So it's understood if you have the nth root of x, that's x to the 1 over n. And so really, to take this further, you could have the nth root of x to the m power, and that would be x to the m over n. All right, so these are some just basic rules of algebra, since we're going to be working with equations. So you've already worked with these since you're all through Algebra 2, but just a reminder, if x equals y, it's also true that y equals x. We're allowed to basically manipulate an equation by doing the same thing on both sides, which is what these next 3 rules all kind of say. Except for a few things that are kind of forbidden, right? You don't want to divide by 0. That's really the one we got to be careful of. All right, so let's get back to the finance stuff. Before we can jump into compound interest, we need to get some definitions down. So I'm going to pause here after we kind of go over what these are. The principal in any financial formula is the balance upon which interest is paid. So that can either be the initial amount you invest in a savings account or the initial amount you take out in a loan. I mentioned this on Wednesday last week, but now here's the formal definition. Simple interest is interest that is only paid on the original principal and it's not paid on any interest added at later dates. Whereas compound interest is paid on both the original principal and on all interest that has been added to the original investment. So make sure you get those down. When you're finished, go ahead and give me a hand raise. That's bright. We're going to start with the simple interest formula. So the way you calculate simple interest, A just stands for amount in the account. So total amount in the account. Your P is your principal. Then you're just going to multiply that by 1 by plus RT. R is your rate as a decimal. And T is going to be time, in years. All right. So banks will almost always pay compound interest. Bonds will pay simple interest. Suppose you invest in a $1,000 savings bond that pays simple interest of 10% per year. How much total interest will you receive in 5 years? And if the bond paid paid compound interest, would you receive more or less total interest? Explain. All right, so we can kind of just do this by inspection. The total, because they ask just specifically not how much will be in your account or how much will the bond be worth, but they ask just how much interest is accruing. So in simple interest, it's just going to accrue interest on the initial investment, on the principal. So if I'm earning 10% per year of $1,000, can change that to multiplication. That's 0.1 times 1,000, which is just $100. So every year I will earn the same $100 in interest on the savings bond, which means after 5 years, I will have earned 5 times that, 5 times $100 in interest. If the bond paid compound interest, that would pay more. And so the logic of that is after the first year, so that first year you would earn 10% on your principal, which is $100 we saw. The bond would be worth $1,100, right? Because it would be worth the initial $1,000 investment plus the interest that you earned, $1,100. After that year, you would earn 10% on that 1,100 instead of just 10% on the initial principal of 1,000. So 10% of 1,100 is now $110. So now, after that year, the bond is going to be worth 1,100 plus 110, $1,210. And then you're going to continue to earn each year interest on the interest, right? So you can see, whereas the original simple interest bond is just going to be worth $1,500 after 5 years, which is the original $1,000 investment plus the $500 in simple interest earned. If we were allowed compound interest, we'd be earning more each year, because you'd be earning interest on your interest. So I'm not going to calculate all 5 years. I'll just say and so on. All right, so compound interest, you earn interest on interest. Simple interest, you only earn interest on the original principal. So how do you compute the amount in an account that is earning compound interest? This is the way that it's done. And this is only for interest that's paid annually, so once a year. So make sure you note that, because we are going to look at, you can't have accounts where interest is paid out more than once a year. So A equals P, which is, again, your principal, times the quantity 1 plus your APR, that's your annual percentage rate as a decimal, to the power of Y, which is the number of years. All right, so let's take a look at this example. You invest $100 into 2 accounts that each pay at an interest rate of 10% per year, but one pays simple interest and the other pays compound interest. Make a table to show the growth of each over a 5-year period, and then use the compound interest formula to verify the result in the table for compound interest case. Okay. So here's how I'm going to set this table up. We're just going to make a table where I'm going to let T be the number of years. This column will be the amount in the account that has simple interest. And this will be the amount in the account that has compound interest. And then up here at the top, just as a reminder, the amount for simple is your principal times 1 plus your rate, which I'll just call R, times the time in years. So I'll call that Y just to be consistent with the other formula that I showed you. Your compound formula is this: principal times the quantity, 1 plus your rate to the Y power. All right, so in both cases, my principal is $100. So I'm going to be plugging in 100 for P. My rate is 10%, so I'm going to be plugging in 0.1 for R. And the thing that's going to change is my y. So I can actually do a little trick in my calculator to make this a little quicker for us. What I'll do is put my simple interest formula. Come on now. I'm going to go to y equals. I'm going to put my simple interest formula here with those values plugged in. So my principal was 100, and I'm going to do times 1 plus my interest rate is 0.1, and I'm going to plug in a variable for time. That's the thing I'm going to change. And then in y2, I'll put my compound interest formula, and I'll plug in those values. So 100, in this case, times 1 plus 0.1. But now it's going to be to the power of years, and I'm just going to put a variable in there. So y1 is my simple interest, y2 is my compound interest formula, and then here x is just going to be the number of years. And I can actually set up a table by going to second window. I'm just going to change the independent variable to ask. So now if I go to table, which is second graph, cool. My x is going to be my number of years, my y is going to be the amount in the account after that many years, and my y2 is the amount for compound interest after that many years. Sorry, y1 is simple interest, y2 is compound interest. So after no years, we have $100 in our account. That's our principal. That's what we're starting with, right? All right, after 1 year, we've accrued 10% of the interest. We have $110 in my simple interest account and $110 in my compound interest account. Now's where you're going to start to see them be different from each other. Because remember, the simple interest account, we're only ever earning interest on the principal. So we're only earning interest on the original $100. Whereas in the compound interest account, we're earning interest on both the principal and the accrued interest. So in this case, we're going to earn, after 2 years, we're going to earn interest on that $110 in the red column as well. Boom. So simple interest account 120, compound interest account now 121. 3 years, simple interest 130, compound interest 133.1. So $133.10. 4 years, simple is 140, compound is 146.41, and then 5 years, simple is 150, and compound is 161.05. So that may seem like, yeah, but it's only $11.05 more, but that's from a very low starting balance of $100. You could imagine how much of a difference this makes if you're investing thousands of dollars, whether you're getting a simple interest return or a compound interest return. All right, so the other thing they wanted us to do was verify that using our formula. So we said after 5 years, we had 161.05. So I'll just make a note of that. After 5 years, simple interest was 150. Compound interest was 161.05. All right, so let's verify that by using our compound interest formula. So if I wanted to figure out how much was in the account after 5 years, I start with my principal, 100, 1 plus 0.1, which is our interest rate, and then I should raise that to the 5th power. So 100 times 1 plus 0.1 to the 5th. And there we go, 161.05. Right, let's keep going. And that's just, once again, the example of the table we kind of just built in our calculator. All right, so now we're going to talk about compounding more than once a year. So in the example we did, the account is only collecting the interest once during the year. Let's see how it affects it if we compound quarterly. So that means 4 times in a year. So if your APR, your annual percentage rate is 8%, but you're going to collect interest at 4 different points during the year, that means you would have to divide that APR by 4, and you're going to collect it, so 8 divided by 4 is 2. You're going to collect interest of 2% 4 times throughout the year. And so if I take just a $1,000 investment and I do that, so after the first quarter I collect 2%, so that's $20. 2% of 1,000 is 20. So now my new balance is $1,020. Then after the second quarter of the year I collect 2%, but now I'm collecting 2% of the $1,020, not just the 1,000. So that gives me a little bit more interest. That's $20.40. And you can continue on. So the way this is different is you're actually going to be earning more money if you're compounding more often. Let's look at what we would have earned if we just compounded once in the year at 8%. So then my account, I could use just my compound interest formula. It would be 1 plus 0.08 in this case, and that's to the first power. So if you multiply that out, you just get $1,080. So it's the same APR, but in this one I'm only collecting it once in the year, and in this one I've split up my APR to be collected quarterly, causing me essentially to earn more interest on my interest and allowing me to earn more in my account. All right, so the more you compound, the faster you will earn interest. So we have to make an adjustment to our compound interest formula then. And this is the formula when you compound multiple times per year. So this is for compounding n times per year. Everything else stays the same in terms of what it means, right? P is the principal amount, APR is your interest rate as a decimal, and Y is the number of years you hold the money in the account. All right, let me do another check-in. Give me another hand raise when you're good with this slide. So we can basically use this formula in the same way, but now we can answer questions where we compound more and more throughout the year. So you deposit $5,000 in a bank account that pays an APR of 3% and compounds interest monthly. How much money will you have after 5 years? Compare this amount to the amount you'd have if interest were paid only once per year. All right, so let's make just a little note. Let's do compounding monthly first. So now we're going to use our new formula. So A equals the principal, which in this case is $5,000, times 1 plus your APR as a decimal, which is 0.03, divided by n, and n is the number of times we compound per year. So if we're compounding monthly, in the chat, how many times would we compound in a year? There we go, 12, exactly. So n is 12. And we're going to do to the power of n times y, so 12 times the number of years that we're going to have it in the account, so that's 5. right? So easy enough. This just goes into our calculator. 5,000 times 1 plus 0.03 over 12 to the power 12 times 5. All right, so $5,808.08. So I wanted us to compare that. Well, what if it just compounded annually? So then our formula just becomes 1 plus the 0.03 to the 5th power So let's see, just get rid of this. Get rid of this. There we go. So $5,796.37. So it has an impact for sure. Obviously not as drastic of an impact as the difference between simple interest and compound interest, but the more you increase the number of times you compound per year, the more yield you will get, the more return you will get on your principal investment, right? Although it does have a limit. Okay. So new definition, APY, annual percentage yield or effective yield or simple yield is the percentage by which a balance increases in 1 year. And then this next part is really important for you to understand. It is equal to the APR only if interest is compounded once per year. If it's compounded annually, the annual percentage yield will be the exact same as the APR. If interest is compounded more than once a year, it will be larger. It will be larger than your APR. All right. So this kind of sums up what that said. The APR is your annual percentage rate. The APY is the annual percentage yield. This is the true percentage that you've yielded on the account. Those two numbers will be equally if interest is compounded annually. If it's compounded more than once per year, then your yield is going to be larger than your annual percentage rate. All right, so let's see. So I'm going to go actually back to our example here, and let's talk about our, oh no, I don't want to do this one because we did it over a 5-year period. Never mind. I'll use the table. Let's just do an example. Let's say, I'm going to do this. Let's say that you invest $1,000 in an account that has an interest rate, an annual percentage rate of 8%. All right, let's pretend after 1 year, if it's compounded annually, versus compounded, let's say daily. And I want to look at what I have after 1 year. So the amount compounded annually would just be the $1,000 times 1 plus 0.08 to the first power. That's $1,080. So my balance increased by $80. So I can figure out my APY, my annual percentage yield, by taking just the $80 it increased and dividing into my principal balance. Well, 80 divided into 1,000 is 0.08. So my APY, my annual percentage yield, is 8%, which is the exact same as what my APR was, right? Now let's say we were to compound daily. Well, that would be A equals 1,000 times 1 plus, I take the 0.08, and if I'm compounding daily, remember I'm dividing by n, number of times I'm compounding. There are 365 days in a year, so that would be to the 365, and I would do 365 times 1 as a power there. All right, so if we look at that, pop that into the calculator. So what we get is $1,083.28. All right, so notice there, we used the same APR of 8%, but now my balance increased by $83.28. So my APY is that $83.28 over the original $1,000, which is 0.08328, or as a percent, 8.328%. So here my APY is different. It's larger than what my APR is, which is 8%. So that's just a little example of why they would be different when it compounds more than annually. All right. So the more you compound, the higher your APY will be. And here's just an example of, in the first column, I have the number of times it compounds per year. And in the second column, I have computed the APY. So when it only compounds once per year, the APY matches the APR. When I increase the number of times it compounds, the APY increases. But you can see it's not increasing unbounded, meaning it's not really getting any bigger than 8.3. Now just the decimals behind 8.3 are changing, right? So there is a ceiling to how much it can increase. Naomi asks, is there a formula to find APY? You're only ever computing APY over a yearly basis, but you can just think of the formula as, it's just the percent increase. So for 1 year. So you can say it's the increase amount divided by the principal. And then if you want it as a percentage, you would multiply it by 100, right? All right. And so, like I said, it does seem to be bounded by something, and it is as you increase. So you could compound daily, then you could compound every hour of every day, then every minute of every day, then every second of every day. And eventually, we get what's called continuous compounding. That's where your account is compounding at every possible moment. And once we get continuous compounding, we end up with this thing called the PERT formula, because sometimes it's written like this, PE to the RT, where R is the APR and T is the time in years. So often referred to as the PERT formula. Where E is that's a natural constant. It's irrational, similar to pi. It's called Euler's constant. It's approximately 2.71828. Your calculator has a button for it. All right, so let's do an example where you would use the PERT formula. You deposit $100 in an account with an APR of 8% and continuous compounding. There's your keywords. You have to know that it's compounding continuous to be able to use the PERT formula. Once you see that, you immediately default to the PERT formula. How much do you have after 10 years? So A equals P e to the RT, where R is your annual interest rate, T is time in years. So $100 times E to my interest rate is 0.08, and the number of years is 10. We'll just go ahead and throw that in the calculator. So here's where you can find E. So 100 times. There's an E above the division symbol, or if you want E to a power, right above natural log, you can do second natural log. You can use either one. So I could have gone, whoops, and then just raised it to a power. 0.08 times 10. There you go, $222.55. And that's it.